Welcome back to the channel. Now let's talk about partial fractions. Now we're going to build up the idea of partial fraction from the scratch so that you will understand it. Then I will resolve questions and show you the techniques and the forms of partial fraction that we have. Now this is following our video or a series on calculus so that you can understand how to integrate partial fractions, of course. I won't be doing integration here. I'm going to be doing another video, but I'm just going to show you what partial fraction is and how to resolve them, all right? So now, what are partial fractions? In order to understand partial fraction, now we must first understand what is called compound fractions. So in fact, it's such that algebraic fractions are divided into two, and they are the partial fractions and the compound fraction. Let me make you understand what I mean. So we have compound fraction, like I just said, compound fraction and partial fraction. Okay. Now, in order to understand this, let me show you what I mean by that. For example, if I say you should simplify this expression, let's say 3 over x minus 2, for example, and plus 2, or let me use a bigger number. Let me use like 5 over x, 3x plus 1. I don't want it to be x again, okay? All right, so let's say we have something like this. If I say you should simplify this, you remember how you do it, yeah? You will take the LCD, right? The lowest common denominator. And the lowest common denominator is just multiply this and this together, right? So you have x minus 2. Just stick with me. I'm going to show you how we arrive at a compound and a partial fraction so that you know how to resolve partial fractions after showing you the forms. So listen. Now, how do you solve this? After taking the LCD, you multiply this first term by the LCD, and this takes care of this and remains this. So you have 3 into bracket 3x plus 1. Does that make sense? Then plus, you say this guy in this LCD, this takes care of this, and then it remains this. So you have 5 into bracket x minus 2. And by the time you have it, you are going to open the bracket and you have 9x plus 3 times 1, 3 plus 5x minus 10 all over our LCD x minus 2 and 3x plus 1. Then by the time you collect like 10, this will plus this to give you 14, then minus, so we have 14x minus 10 plus 3, that will be minus 7 all over x minus 2 and 3x plus 1. Okay, so this is the fraction we have simplified this to. So you see this guy here, we cannot go further from here. So this guy here is going to be called our compound fraction. While the fractions that came together to make up this fraction is going to be called our partial fraction. I'm making sure to check my mic, okay? So this guy is going to be called our partial fractions that gave rise to this guy. So it means that from here, we can reverse the condition and then we'll get our partial fractions back. Now, how do we do that? So I'm going to be showing you two techniques, then I'll now show you the types or the forms in which partial fractions take, okay? Then I'll now solve other questions. So first, let me show you how I can turn this back into this. Now watch me. So I have my compound fraction 14x minus 7 all over x minus 2, then 3x plus 1. Now, how do I make this become this back? Now, whenever we have a compound fraction, we sure know that it came from a particular partial fraction in which a particular numerator a, which is a constant. In this case, why is it a constant? It's a constant because we know that what gave rise to this is a particular constant numerator a over the first part of our LCD, which is x minus 2, and another numerator b over this guy 3x plus 1. Now keep in mind that the value you have on top as your numerator is going to be a degree less than your denominator. So in this case, because our denominator is linear, our numerator is going to be what? A constant. Remember, we go from constant, then to linear, then to quadratic, and more complex and complex like that, complex polynomials like that. So in this case, because our numerator is a linear, our denominator is linear, then our numerator is going to be what? Our numerator is going to be what? Constant. So the same way here, constant. So we know that this is the form of the partial fractions that gave rise to this compound fraction. Now, how do you now find the value of this a and b? And you remember that this looks like this, right? What we are looking for is this 3. Does that make sense? And if you look at it, this also looks like this. So what we're looking for is what? Is the 5. Now, how do you find the 3 and the 5? Now, what you do is this. Multiply both sides by this LCD. Okay? So notice what I first did. I separated these denominators into for two constants because they are linear. For two constants. So with the first constant being the numerator of the first one, plus the second constant being the numerator of the second linear term. Now, the next thing you will now do is to multiply this guy by both, multiply both sides by this guy, by this LCD. So if I multiply this side by the LCD, to cancel the LCD, I'll be left with 14x minus 7, which will be equal to, if you multiply this thing by this guy, it will just be like a over x minus 2 multiplied by x minus 2 and 3x plus 1, right? This will take care of this and it will remain this, right? That will be a, which is the numerator, into bracket 3x minus 1. Does this make sense? So likewise for b, by the time we solve that, x, this one will cancel this guy to remain b and this guy, right? That will be b into bracket x minus 2. I'm just using an arbitrary question here, okay? Because it's very simple. Partial fraction is very simple. Just stick with me if you don't know anything about it before. Now, after this, the next thing you do is, there are two methods you can use. Now, the first method is the cover-up method. Now, the first method is cover-up method. The second method is comparing coefficients or equating coefficients, okay? Now, the cover-up technique is this. I'm going to assume or let, you know that we have two unknowns here, a and b, okay? And we cannot solve for two unknowns at a time in one equation. So what we'll do is that we'll look for a way to eliminate one of the equation. So we say we are covering it up. Now, if I want to eliminate this a and its guy here, I'll just make this guy become 0. So that if I say 3x will become 0, 3x minus 1 will become 0, then 3x will be equal to 1, so that x will be equal to what? 1 over 3. I hope this makes sense to you, okay? So if x has become 1 over 3, then by the time I substitute into this equation, my entire equation, this place is going to give me 0. How? 3 multiplied by x, which is 1 over 3 in this case, will give me 1. 1 minus 1, 0. A times 0 is what? 0. So it means I will be left with this side and this side alone. So by the time we put x into the equation, it becomes 14 multiplied by 1 over 3 minus 7 is equal to b into bracket 1 over 3 minus 2. Okay? So excuse me. This is going to be plus. So don't make that mistake. So it means that from here, this guy goes here, becomes plus, and then, okay, minus 1. So we have negative 1 over 3. So by the time you do that, this will become, this 14 multiplied by minus 1 over 3, and minus 1 over 3 minus 2. Okay, I hope this is clear. Now from here, you have 14 over 3 minus 7 is equal to b minus, now here you have minus 2 number 1 over 3, okay? b into bracket minus 2 over 1 over 3. So from here, I can multiply through by 3. If I multiply through by 3, this guy multiplied by 3 will give me 14, minus this guy multiplied by 3 will give me 21, is equal to, I multiply this entire thing by 3. This will be 2 times 3, 6 plus 1, 7 over 3. 7 over 3 times 3 will give you 7, right? So, but there's negative here, so it becomes minus 7b. Minus 7b, okay? So I can divide, before dividing, I have minus 7 here. 14 minus 21, that is minus 7, is equal to minus 7b, okay? So by the time you do this, you have 7 over 3 times, yes, that's 7, here 21, minus 21. It's not looking like it's to give us B. What is B? B is supposed to be 5. A, is there a mistake somewhere? Here is minus 7, yes. So 14 minus 7, that is, here minus, oh, I'm sorry, our minus here, minus, okay? So that this will be minus this, so by the time we multiply, it's going to be minus, okay? So we have minus 14 minus 21, so that's going to give us minus 35, minus 35, okay, yes. So by the time you divide, it's going to give you 5, okay? Yeah, I just came up with the question there. All right. So, all right. You have to be very accurate. You have to, by the time you solve maths a lot, it's going to increase your accuracy. That's me advising you though. So here 1, here 5, then B becomes what? 5. But I hope you are following me. B is going to be what? 5. Make sure you don't make a mistake like I did here. So B is going to be 5. Now, from here, I know also that I can also let x minus 2 be equal to 0, so that x is equal to what? 2. If x is 2, this is going to be 0, and then we'll be able to work with this alone. So by the time we substitute, we have 14 into bracket 2 minus 7 equal to a into bracket 3 multiplied by 2 plus 1, right? So that we have 14 times 2, that's what? 28 minus 7 is equal to what? A into bracket 3 times 2, 6 plus 1, 7. Okay? So that from here we have that 7a is equal to this minus this, 21. And then we have a is equal to what? 3. Do you see that? So it means that our compound fraction, the way we normally write at the end of the day is that our compound fraction, this over x minus 2, 3x plus 1 is now equal to our a we got to be 3. That will be 3 over x minus 2 plus b, which is 5 over 3x plus 1. And this is the way you are going to present your answer. So this is how we resolve compound fractions into partial fractions. Now let's look at the types that we might encounter. Okay? So now look at the types. Let me show you the types. Now the reason why you need to know the types is because the way you express each one differ. Okay? The way you express it, this format differ with respect to the type. Okay? So the first one you have is the ones that are linear and that have non-repeated denominator. Let me just shorten as denom. Okay? Then we have another type where we have, okay, now let me show you, as I mentioned, let me be showing you. Now, what is a linear non-repeated denominator? Is this example we have here. So example, we could have 3x squared minus 1, 3x minus 1 over x plus 2 and 3x minus 1. So look at this. Here, the expression is linear. Okay? The power on top and the power under are different. How? The power under is quadratic, the power on top is linear. So you see that the denominator is linear. So one thing, the denominator is quadratic. So it means it's greater in degree than the numerator. So you must take note of your question. If I put 2 here, they must not be in the same degree. The denominator must be of a higher degree than the numerator before you resolve, okay? So if you look at this, there's no repeated denominator here. This can be expressed as a over x plus 2. Is this not the question we solved? Okay, it looks like it. Plus b over 3x minus 1. So this is the form in which we express a question like this. Now, what if we now have another form in which we could have, that we could come up with is non-linear but non-repeated, but having no repeated denominator. Okay? Now, what is non-linear? What is non-linear? And that does not still have repeated denominator. My example is, I could have 3x squared now minus 2, for example. This is non-linear, okay? Then over non-linear, okay, it's the denominator that we are talking about, right? So I could have still linear expression on top. So non-repeated denominator is going to be, say I have x squared minus 1. Now let's use a sweet number, minus 5, because if I use 1 there, I can still express as difference of 2 squares, so I don't want anything to affect it. So I have this, okay, then x plus 2. So if I have squared this, it doesn't still affect. The power, the degree of the denominator is still greater than the degree of the numerator. So that's one thing you must always look out for. I will show you when such case, when the numerator has a higher degree than the denominator, we call it improper fraction. And I'm going to show you how we solve it. All right. So this one we express in this form. Now, you see, this guy here is a quadratic denominator, but it is non-repeated. So non-linear denominator, but is not repeated, okay? Now, because it's non-linear, the expression of our unknown is going to be linear x plus b, ax plus b over this quadratic term, not over the linear term. Over the linear term, if you're working with the linear term, it will be a constant over x plus 2. Remember what I said before, that because it is linear here, our degree, the degree of the numerator must be just 1 degree less than the denominator. Okay? So, but for this guy, it is quadratic. So, 1 degree less than this quadratic will be what? A linear expression. So, this is the linear expression here. Ax plus a particular constant, which could be 0 or 1, 2, 3, 4. But it's going to be a linear term at the top. Does that make sense? Now, I'm going to attempt some of these questions. I'll solve some of them so that you see what I mean. Now, number 3 is the one that now has both linear, either linear or non-linear, but repeated denominator. Now, what do we mean by that? The denominator may be linear, it could be non-linear, but it's going to be repeated. So look at this one now. If I have, for example, let's say we still use 3x squared minus 2. Now look this, look at the denominator now. I could have x squared here, into bracket, x squared minus 5. If I have something like this, you'll notice that the power of the denominator is still greater than the numerator, right? X to the 4th here, x to the 4th here, x to the 2nd. So this is still greater than this, right? So by the time you want to express this contains a squared term, which means it is repeated. So what you will do is this. This came from a particular constant over the linear term plus, are you with me at all? A particular constant over the linear term plus, now, because this guy here is squared, it's going to be plus the second term over x squared, okay, because I repeated the same guy, okay, plus, now this guy is just exactly like this, right? So you are going to use a degree less than that guy. So you have what? You have what here? C, because you are going ABC, okay? Cx plus d over x squared minus 5, okay? Do you understand now? Do you understand now? All right. Let me show you another type of non-linear repeated. I could have 3x squared over minus 2 all over x minus 2 all squared and x plus 3, for example. If I have something like this, I will express it this way, that a over, now, if you look at this, the degrees they look the same, but they're not the same, okay? Because this one is squared, so this is going to be x squared times this is going to be x cubed. So this is still a proper fraction. So take note that you must have a proper fraction before resolution. So you have A over the first expression here, which is x minus 2, plus B over x minus 2 now squared, because it is repeated. Then plus, now this one is linear, so it's also going to be what? C over x plus 3. I hope this is clear. You see, all my terms here are linear because all my expressions in each case are what? Linear, but repeated in this place. Is it clear? All right. Then the last form that you are likely to come across in your exam is the improper fraction. The improper fraction. There are two methods I said I will show you here. I showed you only one. So I'm going to use the second method to solve, maybe let me solve this and maybe one of this. Okay? But let me show you the fourth one first. The fourth one is the improper fraction. Now, what is an improper fraction in this case? An improper fraction is one in which the numerator is higher in degree than the denominator, okay? So, for example, if I have an expression like 3x raised to the power 4 minus 2x plus 1 minus 1 over x squared minus 1, x plus 2, for example. X squared minus, let me use a sweet number again. X squared minus 3 over x squared plus 2. Now, looking at this, you see that this degree in the numerator is higher than the degree of the denominator because this is x squared. X squared times x is x raised to the power 3. So it's less. So the first thing you do is this. Open the bracket, okay, of the denominator. By the time you open the bracket, you now use it to divide this. Okay, so maybe I'll also solve this so that you understand what I mean. Okay, so that you understand. So let's start with this. Let's start with this. Okay? Now watch what I'll do. What I'll first do is to multiply these guys together. Now when I multiply this, I'll have x squared times this will give me x cubed. So this is our denominator. Is x cubed minus, or plus rather, this times this, plus 2x squared minus 3x, that's this times this, then minus 6. Okay, so this is my what? My numerator, my denominator. Now, so our equation becomes 3x raised to the power 4 minus 2x. Let's increase it. Let's say like this one was 2x raised to the power, let's say like 2, then minus. Now, I just want the question to be sweet. I'm just inventing it. Okay, let's leave it as 4 then. At 4, at this. Okay? But either ways, just said, plus 4 all over x cubed plus 2x squared minus 3x minus 6. So seeing this, you can now break down this guy. How do you break it down? You divide. So how do you divide? I've made a video on this, so if you don't understand it, just put in the comment section. I'm going to link the video in the description. So I will have x cubed here. This is our divide, so I'll put it here. Plus 2x squared minus 3x minus 6. Then what we are dividing, that will be 3x raised to the power 4 and minus 2x squared plus 4. Now put our quotient here. Now how do you do this? Simply take the first step. You divide to the point where your numerator is now less than your denominator, okay? Your numerator is now less than the denominator, yes. So how many times can we find this guy and this guy? That's going to be what? 3x. Or simply say, what we use to multiply this guy to give you this guy. Okay? That will be 3x. 3x times this will give us this. So by the time you use this to multiply everything, you have 3x raised to the power 4. Then 3x times 2x squared. That will give you plus 6x raised to the power 3. 6x raised to the power 3. You see, this one is not so sweet because it doesn't have a common term here, but we'll still solve it. Let's just. Then minus this times this, 9x squared minus 18x. All right? So you now subtract. By the time you subtract, this will take care of this, and we have 0. Now what you will now have is this. Looking at this, you have 6x. There's no like term on top, so you just bring this guy down. 6x raised to the power 3. Then minus 2x squared minus 9x squared minus 11x. Oh, sorry. Minus 2x squared minus this. That will be plus this. So that will be plus 7x squared. So don't be in a rush, eh? Take your time. Minus 2x squared minus this. That will be plus, right? So then minus 18x, then plus 4. Sorry. 0, you know it's 0 at the top, okay? It has 0. The coefficient of x squared, of x raised to power 1 at the top here is 0. So 0x minus this will be plus. Okay? That's why I told you it's not sweet. Eh? So you have to be careful. Eh? For some questions, you will have all the terms here. So you just be doing your thing. And, you're flowing. You understand? All right? So now, plus 4 minus 0, plus 4. Now, if you look at this and this still have the same power, and you don't want it that way. It's not still proper. The small guy must be at the top, the big guy must be under. So how do you do it? You still divide. This divided by this is going to give you 6. We have plus 6. Plus 6 times this will give you what? 6x raised to power 3. Then plus this times this, 12x squared. 12x squared. Then this times this, minus 18x. Then minus 6. No, minus 36. Then you subtract again. So this takes care of this, 0, right? Then 7x squared minus 12x squared. That'll give you minus 5x squared. Okay? Then plus 18x minus 18x. That'll be plus 36x. See, this one is sweet now, eh? Plus 4 minus 36. That'll be plus 40. Okay? So if you look at it now, this guy is now less than the numerator. Then we can now solve. Okay? All right? So how do we start our solving? Let me re-express. Our question has now become, you see this guy now? Our question will now become 3x. So this thing you have here has now been transformed to 3x plus 6. Because there's a negative here, to be minus 3x plus 6 plus minus 5x squared plus 36x plus 40 all over our denominator. But this time, because we want to resolve the partial fraction that gave rise to this, we will not use the denominator, we'll use this one, which is x squared minus 3 over x plus 2. Does that make sense? Okay. So I said I'll solve this. So let me keep it somewhere too before I clean this place. So let me keep it somewhere. Okay, no. It looks like I'm going to solve the type there. So let me solve this one. Okay? Because this type, see it? You see it's quadratic. You see it? So I'll be solving, let me pick one different one here. Let me solve this one. This one is sweet. So that will be 3x. I'll just keep it here. 3x squared minus 2 all over x minus 2 all squared over x plus 3. This one is also sweet, oh. I'm just picking this, right? Because this one is quadratic again. That's why I'm not picking it. Okay? So let's clean this space. So in order to solve that, I'm going to use the second approach, not the cover-up technique now. I'm going to be using equating coefficients. So I have this as my question. My question has become 3x plus 6 plus minus 5x squared plus 36x plus 40 all over x squared minus 3x plus 2. So what do you do to this? What you do is you express it as a quadratic expression, as a partial fraction. So this will be this case, which will be 3x plus 6. Now, you actually don't need to do anything with this again because it's constant. Not a constant, I mean like it's already defined, okay? So here you can say that this expression here is going to be a over a particular, okay, this is our first term here. Or we can just flip it so that it will be a over x plus 2. But so that it will not confuse you, since this is a quadratic term, we just follow ax plus b over x squared minus 3. Okay? then plus c over x plus 2. Does that make sense? All right. Now watch me. So we are going to be resolving this alone, only this side now. So our equation looks like this plus this is the same as this plus this. Does that make sense? Okay. So what do you do next? You multiply by what? The LCD. So that at the top here, on this side, we'll be left with minus. Remember, we have resolved this, so we are leaving it, okay? Minus 5x raised to the power 2 plus 36x plus 40 is equal to, multiply this place by our LCD. LCD is going to be this guy. It will remain the top, and this one will take care of this. So it will remain the top, which is numerator ax plus b times this guy, x plus 2, then plus c into bracket. When this guy takes care of this guy, it will remain x squared minus 3. Now, we can use cover-up technique by saying that let x equal to 2, and this one becomes 0, then we can solve. But I don't want to do that. Look at what I want to do. I want to use equating coefficient. Equating coefficient. Or coefficients. Or comparing coefficients. Okay? So what I want to do is this. I will express this, which is minus 5x squared plus 36x plus 40 is equal to, multiply this, open the bracket, it gives you ax squared plus 2ax plus bx. You have to be careful, okay? Then plus 2b, then plus, open this bracket, cx squared minus 3c. Now looking at this, what can you do? You now begin to compare, collect like terms first. You are going to see this, it's very sweet. Let's collect like terms of this side. So we have ax squared plus cx squared plus this one and this one. They have power of, x have power of 1, so it will be like terms, we can call them like terms, plus bx then plus 2b plus c plus 2b minus 3c. Okay? So these are the only constants there. Now watch this. We now equate coefficients. The guys that have equal coefficients here, we equate them to the guys that have the same coefficients with them here. For example, there is no way we can ever resolve this and this to give us 5x squared. It is only this and this that we can resolve to give us what? Minus 5x squared. Does that make sense? Because they have the same coefficients. So we can say, therefore, say that minus 5x squared was contributed by ax squared plus cx squared. I don't know if you understand that. Okay, if that's the case, then we can easily say, now, in the next time I'll just cancel this and this and this. How did I do that? I know that minus 5x squared is equal to a plus c x squared. I factored out x squared, okay? So this will take care of this, all right? So I'll just, by cancelling out everything there, you understand what I mean. Like if I divide through by x squared, okay? So it now means that a plus c is equal to minus 5. A plus c is equal to minus 5. So this is going to be like equation 1. Now the reason why people don't like equating coefficients is because it always gives rise to quadratic equation, simultaneous equation, okay? But not all the time though. Now, so we already have an equation 1. We also know that this 36x is going to be contributed by these two guys, right? So we know that 36x, let's come and solve that here. We know that 36x will be contributed by 2ax plus bx. Why? Because they are the ones that have linear term, okay? So we have 36 will be equal to 2a plus b. Let this be equation 2, okay? Then we also know that this constant 40 here will be contributed by only the constants we have here. Those are 2b minus 3c. So from here, we can, let's look at the equations that are alike. For example, there are no two equations that look alike, that have the same term, right? So we can equate one. For example, here we can say that let A be equal to minus 5 plus C. That is, A is equal to what? C minus 5. So we'll now go to an equation that combines A and C. Okay? Or either ways, since let this be equation 3, then we'll now substitute for A in this equation. So by the time we do that, we'll have that 36 is equal to 2 into bracket. A is now C minus 5, then C minus 5, then plus B. So this becomes 36 equal to 2C minus 10 plus B. Let minus 10 come here. So we have 46 is equal to B plus 2C. Does this make sense now? So that it will now be able to work with this. So we have another equation. Let's call this equation 4. So this will be equation 3 and equation 4. Does that make sense now? Equation, okay, like equation 5 and 4. So just label your equations, that's what I mean. So from here, 46 equal to B plus 2C. So you can now solve by simultaneous equation. How do we solve by simultaneous equation? Very simply, you just do this. Let's use the elimination method, for example. We use the elimination method. We'll multiply the top. Let's eliminate B. Or let's eliminate C. If you want to eliminate C, we'll multiply this equation by 2 and multiply this equation by 3. Okay? So if you don't understand what I'm doing here, I'm going to release my video on 6 methods of solving quadratic equation or systems of equation. And so you will understand what I'm doing here. Okay? So this will multiply everything here, and then we'll have 80 is equal to 4B minus 6C. And here we have 3 times 46. That will be 138 equal to 3B plus 6C. Okay, so we can now eliminate this using different signs add, right? By the time we add this and this, we'll get 0. So here, we'll add this and this, we'll get what? 7B is equal to, add this and this, you'll get 8, 1, 2, 1, 8, okay? Okay, yes, it was this that became that, yes. So, and I said I'm solving this. So let's just clean to this place. All right, so we have 7B is equal to 218. Divide both sides by 7. And then you will have here 3, here 1, right? So remainder 1 over 7. So B is equal to 31 whole number 1 over 7. Or let's leave it at 218 over 7. Try to be sweet and easy to solve. Okay, so let's find what our B is now. What our other values are. So since B is 218 over 7, what will C be? Remember, we have an equation that combines B and C. Is this guy. Okay? Remember that 40 is equal to 2B minus 3C. So here we can easily say that 40, let this guy come here and let this guy come here. I hope you understand that. Let this guy come here. It's going to be 3C is equal to 2B minus 40. Now B is this, so 3C will be equal to 2 into bracket 218 over 7 minus 40. Okay, so we have 3C will be equal to, let's multiply through by 21, by 7 rather. So here will be 21C is equal to 2 into bracket 218 minus, multiply this guy by 7. That will give you 7, 280. 280. So you have 21C is equal to 2 times this, 218 plus 218. That's 6, 3, 4 minus 280. So that 21C will be equal to, subtract this, you'll have 6, let's put that there, 280. That will be 6, 5, 156. Okay? So you now divide both sides by 21 over 21. I guess 3 can divide. 3 here 7, 3 here 5, yeah? and 2. That's good. We have 52 over 7. 7 cannot divide 52, right? Because we have 56. So no. So our C will be equal to what? 52 over 7. Let's just maintain these improper fractions, you know. I'm having weird answers, and they are not weird. I'm just having big answers that are not very fine because I composed the questions. All right, so we have had our B and C answers. So what is our A? Recall from there that A is equal to C minus 5, and our C is this. So here, A therefore will be what? 52 over 7 minus 5. Okay, so that A will be equal to, what is 52 over 7? 52 over 7 will be that's 49. 7 whole number, 4 or 3 over 7 minus 5. So easily I'll say A equal to what? 2 whole number, 3 over 7. Which, or 2 times this, 14 plus 3, 17 over 7. All right. So this is going to be our A value. So we'll now present this as everything here is equal to 3x plus 6, 3x plus 6, 3x plus c, now what? 3x plus c, then plus this, which is this, right? Which is ax. What is our A? 17 over 7. That will be 17x over 7 plus, what is our B? 218 over 7 all over x squared minus 3. Then plus, what is C? Plus, what is C? C we got to be 52 over 7. So it will be 52. Let's put 52 on top over 7 into bracket x plus 2. So we can now bring this, because it's common denominator, we'll just bring it down. So our answer becomes, everything on that left-hand side becomes 3x plus 6 plus 17x plus 218 all over 7 into bracket x squared minus 3, then plus 52 over 7 into bracket x plus 2. And this is the resolution of our partial fraction. So you see, it's sweet and simple, yeah? All right, let me see the length of the video. Okay, this is what I will do. I will not finish this because of the length of the video. I'll just show you what to do, and then you finish it, okay? And put your answer in the comment section. Or send your answer to me on WhatsApp if you want. 0902141637. All right, so let me just show you what you want to do. Let me show you what you want to do. Let me show you what you want to do. Now believe, and you will get it by the grace of God. So just believe. Just what? Believe. See, 3x squared minus 2 all over x minus 2 all squared, then x plus 3. Okay? Now looking at this, I will express this as a over x minus 2, the first term, plus b over x minus 2 squared plus c over x plus 3. You see? This is sweet. Okay? So what do? We multiply through by our LCD. By the time we multiply this guy, this side by our LCD, we'll be left with just the numerator, right? Is equal to multiply this side by LCD. By the time we multiply this by LCD, you know this guy occurs twice here. So we'll be left with a into brackets. We'll still have this guy and one of this guy, because there's only one of this guy I have here. So that'll be x minus 2 and x plus 3. I hope you understand what I mean. Multiply this term by this. This is what you get. Okay, just try that. Plus b into bracket, multiply this by this, you left with b into bracket, this guy, x plus 3. And multiply c, that'll be c into bracket, this will cancel this, x minus 2 all squared. Right, so in order to now solve this, you can use cover-up technique. Very simple. You say let x be 2. When you let x equals to here, by making this one equal to 0, you understand what I mean? This guy is going to become 0. So a will be cancelled, c will be cancelled. You'll be left with just this guy equal to this guy. You understand? Very sweet. Then again, you now say let x again be equal to what? 3. By the time you do that, this one will become 0, this one will become 0, you'll be left with this alone. And you'll be able to work it with this, and then you get your answer. Is that clear? Drop your answer to me on WhatsApp or in the comment section if you can. God bless you. Make sure you subscribe to this channel, please. Subscribe to the channel. And I will be, just comment any other video you want me to release on any topic, okay? Whether in physics, chemistry, or mathematics, or even biology, because I started biology series. God bless you.